Hi students, welcome back to my channel. I'm your physics lecturer. In previous video, we just studied the definition of electric charges and electrostatic. The definition of electric charges is it is an inherent or characteristic or additional property of material developed in particle due to which it exerts force on other such particle. So the word additional property indicates that along with gravitational force there exists a electrostatic force. Okay, and electrostatic, the meaning of electrostatic, it's a branch of physics which deals with the study of charges at rest. Now we'll see. Now we'll study kinds of charges. So there are two kinds of charges. One is positive charge and another one is negative charge. Okay. Well, we'll see some of the basic properties of electric charges. So always same kind of charges repel, whereas unlike charges will attract. So the properties are, first one, same charges, if they are positive or negative negative, they get repelled, whereas positive negative charges gets attract. But in examination this is a very important question for 3 marks. Always regularly it is asked. So what the points we have to write for basic properties of charges? The basic properties of electric charges are additive in nature, charges are conserved, charges are quantized in nature. If you mention these 3 points, then definitely you will score 3 marks. So now we'll see one by one what do you mean by additive nature, conserved and quantized nature of electric charges. Additive nature of charges means that charges can be added, just like by applying the algebraic rules we can add the charges. Plus 5 minus 3 gives you the result. So charges are added by applying some simple algebraic rules. So here I have taken one of the examples. Suppose there are positive charges, 5 positive charges and 3 negative charges. So what will be the net charge on that body? Plus 2. See, just like in mechanics, what happens? Linear momentum, energy, everything is constant, conserved. For an isolated system, it remains constant. So similarly for charges they also conserved. They are also conserved or constant, we can say. That means charges cannot be created nor be destroyed, but they can only be transferred. So I have written here the statement: an isolated charge cannot be created nor destroyed but only can be transferred. Now what do you mean by transfer of charge? Transfer of charge means electrification or charging a body. So how we are charging a body, we'll see it later on. How a body gains positive charge or negative charge, that we'll see now. So assume here this is a body. Right now this body is a neutral body, or we can say uncharged body, because here you see, here number of positive charges and number of electrons both are same. If that is the case, then such bodies are neutral, or we can say it as a uncharged body. If suppose this body is losing electron, if suppose this body is losing electron, then definitely in this body number of positive charges are increasing because number of electrons are decreasing, electron are lost. Then this body is rich in positive charges rich in positive charges. Hence, this body is a positively charged body. Similarly, if you consider another same body, okay, now this body is gaining some electron, okay, gaining negative charges. So here excess of electrons, excess of negative charges, so that means number of positive charges are decreasing here. So this body is rich in electrons, hence this body is negatively charged. So in this way we can classify negatively charged body and positively charged body. Now we'll see the third property, quantization of charges. So here you can see a line I have drawn. This line is said to be a continuous line, okay, and the dotted line what I have drawn here, this is a discrete. So your charges belong to this category. So charges are not continuous, instead they are a discrete, means we can count them as 1, 2, 3, and we cannot count them as 1.5 or 1.25. So it's an integral multiple of charges, okay. So quantization of charges means what? It is an integral multiple of minimum charge E. So this minimum charge E has some value, that is 1.6 into 10 raised to minus 19 coulomb. So this is the magnitude of E. This E, if electron is present, then this can be written as 1.6 into 10 raised to minus 19 coulomb. If there is a proton, then the value will be plus 1.6 into 10 raised to minus 19 coulomb. In both the cases, the magnitude remains the same, only the sign changes. Now, this quantization of charge can be expressed in equation, that is, let Q be the charge which is equals to plus or minus n times E, where n is nothing but a whole number. It's a whole number, that is 1, 2, 3 and so on. So I said you it should not be in the decimal, because the charges are transferred as a whole. They won't break up and they won't transfer. Instead, they transfer as a whole. So based on quantization of charge, one question is asked for 2 marks in your state syllabus or board examinations. So here one such question I have. So I'll read it out. A polythene piece rubbed with wool is found to have a negative charge of 3 into 10 raised to minus 7 coulomb.